Hello, everyone. Thank you for joining today's webinar. My name is Leticia Hughes, Director of Global Marketing here at Ekahau. And if you joined a previous session in our webinar series, It's Time for Better Wi-Fi, thank you, and we welcome you back. If in fact this is your first time joining, we hope you find this webinar informative and insightful, and we look forward to having you join future sessions. Now, before we get started here, a couple of housekeeping items. Right now you're in listen-only mode, so your lines are muted. If you need to submit a question, you should type it in the Q&A tool or the control panel. You may also send in your questions at any time during the presentation, and our subject matter expert will address them during the Q&A session at the end. Today's webinar topic is Wi-Fi interference and the impact to performance. And Joel Crane, our technical training manager at Ekahau, joins us, as well as Jerry Ola, our product manager, and they'll both walk you through this very important subject. And I think it's time for us to get started. So Joel, Jerry, I'm going to turn it over to you guys.
All right, awesome. Thank you, Leticia. Welcome to Wi-Fi interference and the impact to performance. Joining me today is our product manager, Jerry Ola. Jerry, how's it going, man?
Going fantastic, Joel, as always. Excited about today's topic as it's near and dear to my heart. And yeah, I think we're gonna make things interesting. Probably break a few things in the process, but you know, that's what keeps it lively, right?
Yeah, that's right. So, ladies and gentlemen, Jerry Ola here has prepared a whole bunch of live demonstrations for us. What do you think the chances of this actually all working smoothly and everything, you know, working how it's intended? What do you think the chances are this all this stuff working?
Oh, I'd give it a 0% chance of everything working and not having any hiccups would be a shocker for sure.
Well, I figured that this presentation is literally about addressing interference, and so if we run into issues, I guess that's just a good example of of interference happening. So, Jerry, one little thing I just want to let you know: I just realized that I am actually my MacBook. 2.0 gigahertz. So if there's any audio hiccups or anything, video hiccups, let me know, and I can probably pass things back. Try to just roll ahead and see if we can get things working. We'll see how stuff goes. So thanks, Leticia, for the great introduction. Just a quick agenda for what we're going to talk about today. We're going to start by kind of talking about what interference is, just kind of defining it. What is interference? We'll talk about the different types of interference that are out there. There's kind of three main types of interference that we run into in the Wi-Fi world. And then this is where we're going to spend the majority of our time is with Jerry going over what some common sources of non-Wi-Fi interference are. And so that part should be really fun. And that's where we expect everything to break. And then we'll have some time for Q&A at the end. And so something to kind of keep in mind throughout the course of this webinar is that there is in Zoom, there is a Q&A tool. It says Q&A. Use that if you have any questions. Go ahead and just plug your questions in there in the Q&A. Also, others can upvote those questions. And so you can just get in there and upvote any questions that other people have asked and put in your own questions, and we'll answer those as we go. Hey, Jerry, how's the audio quality from me doing? I see a couple of complaints here in the chat and things. Everything okay?
When you were talking about your 2.4 and everything was breaking up pretty good, good example of interference and 2.4, I guess, but it at least for me is cleared up since then.
All right, sounds good. Well, I'm gonna turn my video off, and so maybe that'll help a little bit. And if things are really bad, then I will disassociate from my network and reassociate, hopefully in the 5 gigahertz band. So we'll see how that goes here. So let's go ahead and just real quick, just kind of talk about the different types of interference that are out there. We'll kind of talk about what interference is and talk about the different types before I pass things over to you, Jerry. So what is interference? Well, in the world of Wi-Fi, the biggest thing to keep in mind about Wi-Fi is that it's half duplex, which means only one thing can transmit on a channel at a time. So, for example, if you've got a smartphone, oh man, I totally failed with the annotation tool there. Let's try one more time. See, I'm going to blame Zoom for that. That was actually Zoom's fault, not mine. So in the world of Wi-Fi, if we've got a wireless client, like a cell phone, for example, and it's one of these cool new cell phones that has almost no bezel at all. And we've got an access point. These two devices are going to be tuned to the same channel. Maybe in my case, let's say that that's channel 11, because that happens to be the channel that I'm using right now. On this entire channel, on channel 11, only one thing can transmit at a time. So what you might see happen is you might see that the smartphone will transmit to the access point, and then the access point will reply back to the smartphone. One thing happens on that channel at a time. So where does interference come into play? Well, interference is basically any time that something else is using that channel. That could be another Wi-Fi device that's transmitting. That could be another access point nearby that happens to be on the same channel. That could be a wireless video camera or something like that. You know, if you've got a little wireless video camera, check it out. There's my little camera there, and it is transmitting on that same channel. It's going to basically keep our phone and it's going to keep our access point from being able to transmit. Before those two devices transmit, they're going to basically check the channel to see if anything's there. And if something's there, they're just going to back off and they're not going to transmit at all. And so that's kind of the basics of what interference is. Interference is anything that happens to be talking on the same channel as our wireless network, and that will cause our wireless devices to simply give up, just to stop trying and back off and wait for an opportunity to talk. So there's kind of three different types of interference that we have to watch out for. And two of these I'm going to kind of group together here. The first, and I think this is the one that we're going to spend the most time on today, is non-Wi-Fi interference. And so that's devices that are in either the 2.4 or the 5 gigahertz bands, that's the frequency bands where Wi-Fi works. Those are non-Wi-Fi devices can pop up on the same channel as our wireless network and start transmitting. And when they do that, our wireless network basically just has to shut down, just back off and wait until that non-Wi-Fi interference goes away. And so that's the first type of interference. The second, I've got 2 bullet points here, but they're really the same kind, is you could call it either co-channel interference or co-channel contention. Well, with co-channel interference, that's when we have multiple Wi-Fi devices that are on the same channel. So let's say that you've got, here at my home office, let's say I've got one access point, and I've got about 20 devices around the house that are all using Wi-Fi. Only one of those devices can talk at a time. And so, it's going to be a nice, polite conversation. They're going to constantly take turns talking, and that's going to be fine. But they do have to contend for time to talk. They have turns talking. And so that is another type of interference. Now, the last one is adjacent channel interference. Adjacent channel interference happens when we have a couple of wireless networks that, instead of sharing the same channel, are on partially overlapping channels. So for example, if we say that this network right here is on channel 1 and this network right here is on channel 3, those two networks are going to basically constantly interrupt each other. They're not on the same channel, so they're not going to politely take turns talking like we see with co-channel interference, but they are just going to simply yell and scream over each other and interrupt each other all the time. And so that is adjacent channel interference. And so what I'd like to do now is, Jerry, I think we're going to kind of go through some of these common types of interference and talk about what they look like and do some live demos. And so, you think we're ready to go? Do you want to give it a shot?
What's the worst that can happen, right? Live demos and interference and Wi-Fi. Let's see what we can do with this. So I'm going to try and explain this as quickly as we can here to lay the groundwork of what we're trying to accomplish on today's session here. But what we're going to see, move some things off the screen here. I've got a couple things going on here. So one, I've got some live packet analysis going on in the background here, looking at some channels. So what we're going to try and do is show the impact of different interfering sources. And what I've got set up is kind of an over-the-shoulder shot here of my my Surface Pro that it's running the Sidekick, and it's got our layer 1 analysis happening here. And we're also going to be doing our throughput test from that device as well, and seeing the impact from a layer 1 standpoint. But then also, let me turn the camera back on here so that's actually updating live so you guys can actually see that. So what we're going to do is show you the live layer 1, and then also at the same time be analyzing the layer 2 using some of this live packet analysis tools that I have pulled up here as well. So let's go ahead and kind of run through this first lab or demo here where we're talking about adjacent channel interference. So when we talk about adjacent channel interference, and first let's go ahead and we'll just kind of set these windows up here so we can see these kind of side by side. But what I've got set up is the window on the left is doing a live packet analysis on channel 1, and the one on the right is on channel 11. And what we've done is introduced, if we look at our statistics here, we've got several radios that are operating in the spectrum here. So hopefully this comes across okay. I'll kind of zoom in on here so we can see that a little bit better. But what I've done is added a bunch of Wi-Fi radios. I'm in a pretty controlled environment where there's not much outside RF in the environment here. But what I did was I stacked a bunch of radios on channel 11 and around channel 11 adjacently. And then I have kind of my controlled channel of channel 1 where there's really nothing else. We can see some blips of Bluetooth and things like that on the spectrum. But it's pretty clean. It's pretty quiet overall. And you can see that even in the over the time view here, channel 1, we just see that one radio operating on there. And the rest of the spectrum is kind of a hot mess, if you will. You can see there's all sorts of stuff happening beyond channel 1 there with all the adjacent channel interference. So if we look at a little bit more on the layer 1 information before we start running any kind of tests, just to kind of set the baseline here of what we're looking at and what we're kind of introducing is, on channel 1, you can see utilization fluctuating between single digits for the most part, around 10% or less. But then you start to get into, channels 7 and up, and we're seeing quite a bit more.
Hey, Jerry, yeah. I'm gonna let you finish. I think that the optimize for video, I think, is just crunching the video quality to the point where we can't even read any of the text. So, yeah, do you want to try flipping that back away from the optimize for full screen video mode?
Let's try and switch that over.
And also some attendees, and we told you guys that things would probably break, and guess what? They are. Ooh, that's so much better. Yeah, hopefully you guys in the chat. Oh yeah. Jamie says it's better. James says it's better. Chris says it's better. Yeah, cool. Much better. The other thing too is, can you start your video again? I killed your video to try to fix the problem without interrupting you because I didn't want to throw off your groove. As in your lovely face. To all the attendees, what you should be able to do is you should be able to double click on the video source that you want to make the larger of the two. And so if you want to see Jerry's face as like a thumbnail, you can do that. So now, Jerry, we're just looking at the screen from your iPad. That's what we're looking at the moment here.
Okay. So yeah, I try to blow that up a little bit, and hopefully that comes across pretty clear. We'll kind of flip between these to try and see everything, but we'll try and, my hope was that we could kind of capture everything in a single pane of glass.
Yeah.
And we can analyze this from layer 1 up the stack, right? So looking at layer 1 here, this is the utilization from an RF energy standpoint, and this is just no traffic for the most part, right? This is mostly just management traffic. Honestly, I don't even know if I have any devices connected on the 2.4 side right now. So this is for the most part just management traffic. And you see a few little Bluetooth hops and stuff because I'm using a Bluetooth headset, but pretty clean, right? And you can see already a difference, right? Just because of the adjacent channel interference, without even any traffic, without any clients on here. Look at our utilization on these channels that we're introducing adjacent channel interference of just management traffic. We're seeing 10, 20% utilization, really double the utilization already on these channels without even introducing any traffic. So yeah, let's go ahead and get into some interesting stuff here. And what I'm going to do is actually connect. Okay, so I do have my adapter here connected to my controlled network, which is the channel 1. And let's go ahead and run our baseline test. And what I'm going to do is start up the throughput test in Ekahau here. And you should hopefully be able to see that in the top of the screen, what we're able to achieve on that kind of control channel, right? And you can see we're maxing out the channel really for the most part on this utilization. You see we're achieving about 99% utilization. So, this is really what this channel is able to achieve with the configuration I have for throughput. And it's staying pretty steady. If we look in the top right, yep, thank you, Joel. We're seeing about 50 megabit per second pretty consistently there. Now let's go ahead and look at some other interesting statistics on the layer 2 side. So let's go ahead and flip over to that packet analysis. And this is the one here that I've got set up to do channel 1. Joel, are you able to see this text okay? I can try to make it a little bit.
Actually, I can see the text really, really well, and I'm getting a lot of feedback saying that some people are. It says it's working just fine. A couple people, I think, that you're not able to see Jerry's screen share. We did turn Jerry's video feed off. Even though it's nice to be able to see Jerry sometimes because we can kind of live far away, but. I did turn that off. And if you can't see the screen share from Jerry right now, just hunt around. Make sure that there's not a window hiding. Zoom, I think, kicks it out into its own window. I see overwhelming feedback in the chat that it's working great. Austin says to get out of full screen, then double click on the screen share, and that should work great. Robbie says it's working awesome. So
awesome. Thanks, guys.
Yep. So yeah, go ahead, Jerry. This looks really good.
All right, so here's my layer 2 analysis. We're doing a live packet analysis here, looking at the statistics about the packets that are flying through the air right now, and specifically on that channel 1. This is our control channel. This is where we don't have any or adjacent channel interference really being introduced, and we're doing a throughput test, and it's measuring the results. We can see we're using MCS 15 for our MCS rate on there 58% of the time, and some MCS 14 as well. So it's kind of going back and forth between those. But the majority of our traffic is all going out at that MCS 15. So everything's looking really good there. If we look up on the top right, we can see our retries and under 10% utilization consistently on that channel as well. So, really as far as 2.4 goes, in a pretty clean environment, you're still going to see retries. You're still going to see some fluctuations. That's Wi-Fi. But this is really our baseline, right? This is our controlled environment.
So Jerry, I have some questions for you. First off, so you say utilization. Can you explain exactly what utilization is, what spectrum utilization is?
You put me on the spot, hey?
I am.
The difficult questions. I feel like you're the better person to answer that question. But
I could if you want, but I want to give you a crack at it.
I feel like you ask a wireless engineer that question, you're going to get a different response from every engineer and some different interpretation of that. But yeah, sure. Utilization. So we're looking at spectrum utilization here, and that is the amount of time in my eyes that the spectrum is being observed as being busy, as occupied, right? So there's energy that is being transmitted, and right now we're looking at a duration. If we look on the top of the screen here, we can see a duration value of 1 second. So the amount, that percentage that we're seeing there is over a 1 second duration. What percentage of the time was that busy? If we change this to something like, let's say 10 seconds, it'll recalculate there, and we'll see those numbers update a little bit slower and be a little more steady at a certain percentage now. So now we can see that kind of slow things down a little bit, and now see an average over 10 seconds. What is the amount of time that channel was observed being busy?
All right. So how busy is that channel over the last 1 second, 5 seconds, 10 seconds, whatever time span you have selected?
Yep.
The next question.
What percentage it was occupied, right, is another way to kind of.
Gotcha. The next question that I have, and this is kind of some feedback from the audience here, I'm kind of keeping an eye on the chat, is what is MCS 15 compared to like MCS 1? What is MCS all about? What's going on? Basically, what's going on in this column right here?
Yeah, so MCS is the modulation encoding scheme that the access point and the client are talking at. The speed at which they're talking at is how that's determined. So that's where your data rate is derived from, and MCS is determined. Different vendors. It's all those kind of vendor proprietary kind of things, but for the most part, it's based on SNR. So if you have good SNR, you can talk faster, right? We can get our information across quicker. The receiver on the other end can hear it and understand it, and can reply back very quickly. So higher MCS rates tend to equate to better experience, right? Better client experience, better customer experience from a Wi-Fi standpoint.
So the higher the MCS rate, the faster of a data rate we're able to use.
Yep. Exactly. Yep.
Cool. All right. Now I said I was going to let you finish, and now I'm actually going to let you finish. So go ahead.
All right. So now let's go ahead and change gears over to our disaster of a where we were seeing the higher utilization on the management side, right, which is where our adjacent channel interference is. So I'm going to connect to this SSID, not that one, actually, this one here. And what that's going to do is move us over to this danger zone here in the 2.4, and you'll see we're now connected on channel 11 as indicated here with this in gray and bold here. And now we can see the utilization creeping up. Our throughput test is resumed. And yeah, we'll look at now our statistics. And let's actually pause the previous statistics here on 1 so we can kind of use that as our baseline. And now let's compare the results on the channel 11 here. So I've got this adapter or this packet analysis looking at channel 11, and we've now used this as kind of our baseline here to see what if any, are differences. So we're in pretty close proximity to the APs. So SNR is still going to be good, even though we're introducing some adjacent channel interference. And keep in mind, this is not even a terrible situation as far as adjacent channel interference. We're introducing a lot of management traffic, or a fair amount of management traffic with the adjacent channel interference, but there's not a lot of data. None of these APs, they're just kind of lab APs that don't have any clients associated to them. So as you can kind of see, even on the spectrum utilization, there's not a lot going on there as far as as far as the utilization on those adjacent channels. Now, if we introduce more traffic on those channels, it would even get worse. But even with just management traffic going across those and that adjacent channel interference from those neighboring APs, notice the difference on things like retries. However, MCS-wise, not too much different. We're seeing a little bit more being put on some of these other data rates and MCS rates. But for the most part, we're still able to get a lot of our traffic out at MCS 15. However, our retries are higher. So, we're looking about 5% or so higher so far on this example.
Hey, Jerry, question from the chat. And also keep in mind, audience, if you have questions, and the Q&A tool is a great place to put those, but also the chat is great for, just some kind of general chit chat and things like that. One question that's come up a few times is, what tool are you using? What tool is running here in the terminal windows?
Yeah, so this is a fun one. This is actually kind of one of my favorite tools. There are some limitations with it. It's a text-based kind of application, but it's called Horst. HORST. I believe it stands for Highly Optimized Radio Scanning Tool. So try and remember that one. But yeah, really lightweight packet analysis is what I like about it. It runs in Linux. So these are actually running on WLAN Pis. And this Horst application, if you're familiar with the WLAN Pi, I'll do a little shameless plug there for, that's a little pet project of mine, WLANPi.com. You can check it out if you want to build one yourself. It's a nice little portable Linux computer. You plug an adapter, and now you've got a nice lightweight packet analysis tool. However, the biggest limitation that it does have to be aware of is that even though I am using an 802.11ac adapter, the Horst application, it's a little dated and has not been updated to do statistical analysis type stuff that we're looking at here for 802.11ac traffic and frames. So works great for doing some of these kind of lab things and looking at things on 802.11n, but starts to kind of fall apart a little bit on the AC traffic. So certainly not a professional, robust solution for today's things, but works great for this kind of lab environment.
Very cool. Thanks for the explanation.
Yeah, so there's our first test, right? So that kind of laid the groundwork of what we're looking to accomplish here today. We're looking at things from a layer 1 standpoint and a layer 2 standpoint. And this, we're not even introducing any interference outside of just our own APs, right? Or neighboring APs. And this is a, very common situation that we're, that we see in the real world, right? So, yeah, what do you guys think? Is that helpful to kind of understand and see, does that make sense? Any questions coming in, Joel?
The chat has been continuously blowing up, and I've been doing my best to keep up with it. But it's been it's been rough to try to keep up with it. There's just lots of great discussion stuff happening in there. So just to kind of make sure that I'm kind of understanding what's going on here. The three main measurements that we're looking at right now is, I'm going to circle these on the screen. First off, spectrum utilization. How often is the channel being used, right? And that depends on kind of the level of interference, right? Next is how many retries how often do we have to retry to send data? You know, how often does a data frame fail to send? And then finally, what data rate are we statistically seeing being used on that channel? That kind of seems like that's the three primary measurements that we're looking at. Am I on track there?
Yeah, I think that I think with those three things, you know, we can get a much better picture of what is the impact of, you know, the interference, and in this case, you know, we're looking at adjacent channel interference versus, you know, either no co-channel or adjacent channel, or at least no adjacent channel interference on the channel. And you know, here's a good, just kind of simple way of representing that.
Very cool. And also, just so everybody's kind of clear, these two windows over here are Horst. And then we should probably mention this since we work for Ekahau, and this is an Ekahau webinar. This is Ekahau site survey that's showing our spectrum over here, and the spectrum analysis data is coming off of the Ekahau Sidekick. And so, but Jerry, we are terrible salesmen. We didn't even mention that this is like our tool that we sell and stuff.
Minor details. You know,
yeah, I guess that's true. I don't know about you, but for me, it's all about the tech and it's all about the fun tools and things like that. So,
that's right.
So cool. Where do you want to go from here?
One other thing I would mention before we move on is also notice spectrum utilization. Remember on channel 1, when we had that nice clean channel, we were hitting 90% and even 99% spectrum utilization on that channel. However, notice, you know, running the exact same test, I didn't change anything with the throughput test. Notice we're not able to achieve the same utilization of the channel. Any ideas why that would be, Joel?
Oh, wait, I'm sorry. I was looking at a question in the question tool. Can you repeat that?
So I was throwing you a little bit of a curveball here on the spectrum utilization that we were talking about before.
I'm ready.
But notice the utilization is much lower on the channel with the adjacent channel interference versus our clean channel. We were able to achieve 99% utilization. In my eyes, or at least in my experience, a lot of times people look at that as the inverse and they see, oh my goodness, this channel has 99% utilization on it, and they think it's a horrible thing. But if you're able to achieve 99% utilization and, you know, you're pumping Wi-Fi traffic through there, that's actually showing that you're efficiently using that channel and using the spectrum. Where here I'm pushing as much throughput as I can on this channel, but I can only utilize that channel 75% or so of the time. And that just shows how that adjacent channel interference is causing a lot of back off on the channel, right? So there's a lot of dead air on the channel is essentially what that equates to. 25% of the time, that channel is basically, you know, backing off because of all the adjacent channel interference.
And I would even take that a step further and say, you know, you're very rarely going to get above about 70% utilization, because Wi-Fi, you know, in the protocol itself, how Wi-Fi works, there's a lot of dead air, right? I wouldn't say a lot of dead air. That's probably not accurate, but there is some dead air in there. There's some times where, you know, devices are, the channel has to go quiet for a second just for devices to figure out who's going to get to talk next and things like that. And so I don't know that the maximum utilization that I ever see is like 70-75%. I usually typically don't see it go above that. Is that do you have pretty similar experience as well with that?
Yeah, definitely. Yeah. Well,
Cool.
Let's change gears here and you know, get into the fun stuff here. So we've got some interfering sources. I don't know how well you can see this on my camera.
Very well.
But yeah, so what we're doing is we're going to introduce some interference, and this is a little wireless video camera. This is a 2.4 gigahertz wireless camera, and it's battery operated. And we'll go ahead and turn this on and look at our statistics and our utilization and things like that, and what happens to the spectrum. So I'm going to start out kind of putting this thing in the middle of the spectrum, not right on top of the channel that we're using, but next to it, kind of adjacent to it. And let's see if we notice any difference in our throughput as well as in our utilization and things like that on the channel, right? So notice actually my utilization is going down on channel 11, right? And notice my throughput test up on the top. What happened? We killed it. It actually cannot pass any traffic on that channel at all. And we're seeing that, pretty much everything has kind of come to a standstill on our spectrum utilization, or our packet statistics here when it comes to actual data that it's moving. I'm seeing some beacons coming through at, you know, those really low 1-2 megabit data rates, but we're not seeing any data traffic coming through anymore. Everything's kind of come to to a halt there, right? So yeah, the only traffic that we're seeing is some of that really low, slow traffic that our adapters that are doing the statistical analysis. That's the only thing they're hearing.
So just to make sure that I'm up to speed here, we've got in Horst over here in this terminal window, we've got the packets column, and I'm looking at the data packets, and it looks like it's a little hard to read because it's blue on black, but it looks like it's around 7,600 packets or something like that. Whereas our beacons, we've seen 52, 53, 54,000. So we're still seeing access points saying, hey, I'm here, but we're not seeing any data traffic coming through at all. Is that correct? Am I tracking properly there?
Exactly, yeah. So it killed the throughput test altogether. I turned the camera off now. You can see my device actually roam back over to that channel 1, which unsurprisingly, the channel that didn't have any adjacent channel interference on it preferred. So it went back over to channel 1, and you can see my throughput test is going strong again, and everything's looking pretty smooth there. But yeah, so we can see, that's really what happens in these kind of environments where, some type of interference comes in and, maybe temporarily come in, and then it, may go away. And actually, while I'm thinking of it, I should have my interference detection turned on, the experimental interference detection feature. And what that does is allows me to also show that interference. And there we go. We can actually see that it's a video camera that was detected and what area of the spectrum it was impacting. So yeah, to kind of, I should have maybe specified this before, but this is what we're using here in the setup. I've got my Echo Sidekick connected to the Surface Pro, running Echo Site Survey Pro. We're analyzing the layer 1 and doing our throughput test all on this device. And then on my other screen here is what we've got the we've got the packet analysis pulled up there. So yeah, just see that again.
Can you show? Yeah, thanks, because we couldn't see it the first time.
Yeah, I just realized I had my camera covered up there. There you go. Thank you. So yeah, there's our Sidekick connected. I've got a few other interferers here, but yeah, I see we're already getting up there in time here. So I want to make sure we make the most of everybody's time here on the call. We've got several other interferers that we can play around with and see what kind of impacts they have. We can see the video camera just completely dominated, even not putting that directly on channel 11, completely disconnected the client device here and made it move over to a different channel and really stopped all traffic in that whole area of the 2.4 spectrum. But yeah, we can look at some other devices. We've got a wireless controller here. This is for like a quadcopter that operates in 2.4. We also have some wireless keyboards. We've got some other transmitters here that operate in both 2.4 and 5 gigahertz. So yeah, what does the audience think? What would you guys like to see? I've got a microwave oven. We could compare some of that kind of stuff. We've got a signal generator device here. This is running some custom firmware that we can do like a jamming mode or signal generator mode, and we can see what that does to the spectrum.
So it sounds like we need to give the audience some options. You want to list them out really quick, and I'll type them in on the screen. And then audience, you can use the chat to do an informal vote on where we should go from here. So what are our options there, Jerry? Go ahead and list them off.
So on the 2.4 side, we've got our wireless controller for quadcopter. We've got our wireless keyboard here. This is a 2.4 wireless keyboard. We also have, some Bluetooth devices. We've got a microwave oven. And then on the 5 gigahertz side, we've got a motion detector. This would be like a motion detector you have on the ceiling that operates in 5 gigahertz. We also have a drone controller. Took the module out of a 5 gigahertz for a quadcopter drone, and that's actually a pretty high output one. And then we also have this fun device here that will generate signals on 2.4 and 5, and basically act as a jammer.
Cool. Okay, so I just threw those on the screen, guys. It's kind of over there on the baseline Horst. So why don't you use the chat, and I'm just going to try to get a feel for what everybody wants to see. Throw it. Okay, I'm seeing microwave. Cool. So tell you what, let's pick two. So let's do the microwave for 2.4, and then Dan says anything in 5 gigahertz. And so yeah, I think I'm with Dan. Let's pick something up in the 5 gigahertz band. What do you guys think? The motion detector, the drone controller, or the jammer? What do you guys want to see? Jammer. All right, cool. I think the audience has spoken. So let's take a look at that microwave in 2.4, and then we'll switch up to 5 gigahertz and take a look at the jammer.
Cool. Well, I just reset my packet statistics on Horst here, and yeah, let me go ahead and turn the microwave on. I got the microwave outside of the room here, so give me 1 second. I didn't want to be cooking stuff in my office, so we'll
Sure
see
thing.
how it
I'll
goes.
talk about some stuff while you're gone, so I'll fill the air. I'm very good at doing that. So first of all, everybody, thank you so much for for kind of sticking with us through these demos and stuff. Jerry and I, we kind of tend to not do slides and to kind of do this, and so sometimes it's a bit of a train wreck, but I think it's pretty fun. What I want to talk about real quick while Jerry is gone is just the different impact of that we have of interference. Like what happens with interference? There's several different measurements that we can use. One of those is utilization. Remember we talked about this. This is basically how often is a channel being used. And so in this little example right here, you can see that my spectrum utilization is 36%, right? Another one that Jerry is measuring using Ekahau Site Survey is throughput by doing what's called an iPerf test across the network. And so that's just passing normal traffic back and forth, but seeing how quickly we can move that traffic. Another measurement that you want to keep a close eye on, and Jerry is using Horst on the WLAN Pi to do this, is data rates and MCS rates. They're really the same thing in the end. When you look at a data rate versus an MCS rate, they're the same thing. So don't get too caught up on that. Also, retry rates. How often do we have to retry to send a frame? How often is a frame not delivered successfully the first time? How often do devices have to try again? And so I just kind of wanted to go over that really quick and talk about what those different measurements were. And these are some of the main ones that Jerry has been showing today. So Jerry, you back? You ready to rock and roll here?
All right, so yeah, while you were talking there, I did a quick test of the microwave on the control channel, and as expected, I didn't see a whole lot going on there. But
I stole your screen, so you might want to share it once more. I totally stole it from you.
You stealer.
I know. I'm awful.
Here we go. Okay, so yeah, while you were talking, I did a quick test of the while I was on the control channel, and didn't see much impact on there. But let's go ahead. I'm going to turn the show interference off here so we can see a nice view of this. Get my iPad camera back
and
on.
since I switched the video sources around, just the audience, there might be a floating window somewhere. Definitely get out of Zoom's full screen video. And look and make sure, just click around on stuff, and you should be able to switch away from Jerry's face back to his screen share. So just look, there should be a screen share video there somewhere.
All right, so you guys can see this now. So we've got
several people are reporting that they can't see it. So my bad for stealing the screen to kind of explain some stuff real quick. I can see it over here, so I think it's being shared.
Okay.
Brian says yep. Rashan says nope. Jared says yep.
Well, hopefully the recording will come through okay. And yeah, if you miss any of this kind of stuff, I know. Yeah, I figured something was going to break along the way with all the switching back and forth and using an iPad to do our camera and everything here. But yeah, let's go ahead and
everybody in the audience, it is being shared. Yeah, go ahead and just look. It is being shared somewhere. Just try to find in Zoom where it is being shared. We'll talk to the Zoom people and see if we can find a way to solve this for future webinars. Nick can see it. Yeah, it's there somewhere. Keep hunting for it.
All right, cool. Well, here's our test running, and I'm going to go ahead and turn the microwave back on here, and let's see if we see any difference. Before I do that, I'm just going to reset my packet statistics. So we're back on channel 11 here. Let's actually move this over a little bit so we can see both of these kind of up at the same time. And yeah, let's go ahead and try this out. All right, so I kicked in the microwave here. Any difference to our throughput?
So what was the throughput before? I wasn't paying attention. I see it's 5.5 megabits.
Yeah, we were pretty consistently about 50 megabit per second, and yeah, it dropped down to 5, and now it's just dead altogether. So this is outside of the room that I'm in. So this is not near. This is actually pretty close to the access point that we're connected to, but it's pretty far away from the client device. It's on the other side of a wall and a door, and that's enough to completely kill at least the upper half of the 2.4 band. You can see channel 1, actually utilization is really low, so it's really only impacting those upper channels. But yeah, definitely can be causing some issues. So I think the important point of this here is that the location of the microwave in proximity to your receiver, either your client or your access point, is an important thing to keep in mind as far as design and yeah, placing these types of things. Yeah, notice the noise level on the channel there as well.
Yeah, it's just through the roof. Several people in the chat are asking, like, is your microwave door open? I hope it's not.
And you can see a little closer view of the spectrum there as well, what that kind of looks like. So yeah, that was one. Was there another interference that?
Yeah, we universally, no, well, not universally, but we had an overwhelming vote earlier on to take a look at the 5 gigahertz band and look at the jammer up in 5 gigahertz. So,
all right, jammer it is. All right, so let's switch over to the 5 gigahertz side. One of the things that's nice with the Sidekick, if you're not familiar with it, is the entire time we were looking at the 2.4 side, it was capturing everything going on the 5 gigahertz side. And like I said, I'm in a pretty controlled environment, so we're not seeing a whole lot going on here. Let's go ahead and kind of mess up the 5 gigahertz band a bit. So I'm going to start off by connecting on my control 5 gigahertz. We set up a separate kind of lab here to also show co-channel interference on the 5 gigahertz side, so we can look at that if we have time as well. But I'm going to connect to the control one, which is a 40 megahertz wide channel. We can see my throughput test is going, and yeah, already we're seeing much better results now that we're using a 40 megahertz wide channel, getting closer to 100, 150 megabit per second on that channel consistently for throughput on the iPerf test. And yeah, let's look at the channel, look at our utilization. Things are looking pretty good there. Yeah, I'm really not even coming close to maxing out the channel. I kind of limited the throughput test, so I think it's only trying to achieve about 150 megabits per second. So we easily should be able to push about 300 megabits per second if we're looking at purely by utilization on those 2 channels there that we're pushing data across. All right, so let's go ahead and look at our next weapon of choice here, if you will. So here's this is the Porta Pack. See if I can get it to focus here. Zoom out a little bit. This is the Porta Pack running a Havoc firmware. And what this allows me to do is put this into different receive and transmit modes. So one of the first thing we'll do is go under the utilities here, and we'll use the signal generator, and we can generate different shapes of waves here. But I'm going to generate something on the 5 gigahertz side. So we'll go ahead and tune into channel 149, for example, to test this out. And let's go ahead. It looks like are we on channel 153, hey, Jerry, actually.
Let's kill your screen share and bring it back up. We've just got a ton of people that are just saying, I mean, I'm seeing it over here, no problem, but I think there's a lost window or something on quite a few machines. And so we're going to kill that to try to fix that. Yeah, Dan says he's having no problem. So we know that it's at least being shared. I think it's being lost. And so Jerry just restarted his share. For everybody that's having trouble, we do apologize. We're not sure what's going on here. We will talk to Zoom about this and see what we have not had this issue before, and we've done a lot of webinars, so something weird going on. All right, everybody says it's there; they can see it now, so perfect. Jerry, go ahead.
Live demos.
Yeah, right.
All right, so let me make sure we've got this. Still, it looks like maybe this changed networks here. Let me make sure. Yeah, so we're back on 2.4. So let me put this back on the 5 gig. And all right, so I've dialed in my frequency here on the signal generator. And let's go ahead and see if we can see this show up on the spectrum. And it's pretty small. This is a pretty fine fine signal here. Let's zoom in on the spectrum here as well to kind of help see this a little better. And this is actually sitting right at the end. You can see this little tiny sliver here. Let's zoom in a little bit further on the spectrum. Yeah, see that tiny little sliver right in the middle there? That's our signal generator. So this is a tiny little signal, and I'll actually move it over to the right here a little bit, get it a little closer to our channel. And notice our throughput up on the top. Can you guys see that?
Not quite. The video is just a little bit on the small side for us to be able to see it, but we can probably take your word for it if you want.
So 1.8 megabits per second, and now we disconnected. So now my internal adapter here on my laptop is disconnected. And this is why we're doing this kind of hokey setup with the iPad over the shoulder shot, is because I knew that we were going to be disconnecting this adapter pretty regularly. And so I didn't want to keep it disconnecting. So yeah, that's why we're doing this kind of weird screen share type thing with you guys.
We couldn't do a direct screen share from the laptop because we are literally jamming the laptop over and over and over again. And so that's why the iPad is functioning as our video camera.
Yep. Yeah, so there we can see it disconnected, and actually, yeah, where did it go? Let's see. Yeah, it is still there, but nothing is actually transmitting on there anymore. So yeah, it's actually gone. That channel's gone very quiet altogether. Even from the AP, it's not even sending out beacons or anything. Oh, that's because I got a 10-second duration. Okay, let's turn that back down to 1, and we should see.
Or did it roam down to 2.4 gigahertz?
Well, my client device did disconnect from it, but yeah, you're right. It's back on 2.4, but let's put it, I was trying to see if we were even seeing the AP back up. Here's my control. So now that did come back. There we go. Okay, so now we're connected back to, or it's connecting. There we go. Now we're back on there. And let's just do that one more time so you can see. We'll wait for our throughput test to start back up. See if this laptop will stay connected to it. Yeah, okay, we're connected on the control. Let's see if my throughput test will start back up. There it is. Okay, throughput test is back up and running. Got my havoc and zoom out a little bit. So we're going to go ahead and start this, and let's see how quickly. Watch that throughput in the top right there. And as soon as I start the throughput test, start the transmitting the signal, notice the channel just go completely silent, right? Our throughput actually just completely died. It's still showing that 131 up there because that was the last that it got, but there we go. Now it just stopped the throughput test altogether. Not able to send or receive anything. And oh, actually it's, oh, it switched now. So now we see we're starting a throughput test again, but it's back over, it roamed back over to the 2.4 side.
So what you're saying is that you jammed out the 5 gigahertz band, and so your client device, your laptop that we're looking at through the eyes of your iPad there, roamed over to the 2.4 gigahertz side.
Yes, correct.
Wow. Yeah.
And this is a really low power transmission that we're doing here, but because we're in so close proximity to the client device, that's the effect that it's having.
Wow.
Let's go ahead
Very
and do
cool.
one more test here. I know we're already getting at the top of the time that we had allocated for today, but I'll do one more test here on the jammer side just to kind of show the difference.
So one more test and then Q&A?
Yes, yeah.
All right.
Sure. So yeah, go ahead and get those questions in if you haven't already.
Yeah, use the Q&A tool, and it should be down at the bottom of the Zoom window. Should be a little icon that says Q&A down there. Dawn has a question though. What's the brand of the signal generator that you're using?
So this is actually kind of a homebrew device. This is using a combination of a HackRF is the underlying board inside there. If you're familiar with the HackRF, it's a pretty popular one. And then there's kind of a bolt-on accessory for that called the Porta Pack. You can see on the screen there. And then it's got some custom firmware on there. So this is, yeah, definitely a kind of a homebrew solution, if you will. But yeah, it's great for doing these kind of lab things. It does both transmit and receive functionality and works in a wide range of frequencies. So yeah, let's go ahead and put this back on. Actually, I'm going to put this on 149 since that's our wide channel. And let's see if we see any difference if we jam just one of the 20 megahertz wide channels and not the other. So you can see right now we were doing about 150 megabit per second, and I'm using the, oh, range is not load. Oh, I gotta check the box here, sorry. Let's go ahead and start that. And yeah, here you can see the jammer kicking in. Oh, let me zoom back in. And you can see that kind of coming across. It's doing these little slices through the channel 149 there. And notice my throughput. Still going, you know, the throughput test is still going, but a huge impact to the performance, right? Because we're sending it across a 40 megahertz wide channel. And now if we looked at retries, unfortunately, Horse won't work for this, being that it's on 5 gigahertz and 211 AC, but we can see that it's really killing the throughput. So I'm sure our retries have increased quite a bit as well. Turn that off, and then we should see things normalize there pretty quickly. You can see my throughput shoot back up right away, so we're back up to over 100 megabit per second. Well, cool. We're already over a few minutes. I want to take the rest of the time here to stick around and answer any questions that we can. You want to turn over to Q&A, Joel?
Yeah, sure thing. So let's go ahead and just kind of go through some of the questions and things here. And Jerry, what I'll do is I'll just kind of read some of these, and we can just kind of tag team all of these. So yeah, feel free to use the Q&A tool and go ahead and put those questions in there. And you can also upvote anyone else's questions if you see a question there that you really like. Yeah, we'll go from there. So let's see. So a question from Milton is, can you identify what kind of interferer it is with the Ekahau tool? Can you identify what kind of interfering device it is?
We are starting to be able to do that, yeah. So that was that interference classification that we've introduced, and in the Ekahau 9.2 build that's out available, currently, you can enable that kind of hidden interference detection or interference kind of classification capability, where you can have it show interference. And especially on the 2.4 side, there's quite a few signatures in there. It'll detect things like video cameras and different types of non-Wi-Fi sources of interference that you'll see commonly in the 2.4 side. That database is still being kind of built out, but if you want to access it, you hold down your kind of hidden modifier key, which on the keyboard here is going to be your control key in Windows, Alt Option in Mac, and you're going to go ahead and click on that Sidekick icon. This does require an Ekahau Sidekick. You need the speed and the resolution of the Sidekick to be able to properly classify these. But yeah, then you're going to check this box here to enable the interference detection, experimental interference detection capability. And then the last piece is to, set it to show interference. So that'll unlock this mode here, and then you can tell it to show interference or not.
Very cool. All right, so I'm just going down the list of the most upvoted questions here. Question from Jory is about co-channel interference. How many dBms should there be between two access points that are on the same channel? Jory, my opinion there, this is just my opinion, but I'm going to say shoot for, if you're standing next to one AP and there's a distant AP, it's on the same channel, I would try to keep that distant AP at no more than negative 85 dBm. My understanding there is that negative 85, if a Wi-Fi client hears something else on the same channel at neg 85 or below, it will simply ignore that and it will transmit anyway. Jerry, is that true, at least in your mind? Am I on track there?
Yeah, I think that sounds realistic.
Yeah, I think that's I think neg 85 is the one. So try to keep your same channel APs below neg 85 dBm. So
yeah, I mean, keep in mind your APs have better receive sensitivity typically than your clients do. So yeah, I mean, there's that piece of it as well, right? So you got to think of the APs, but you also have to think of the clients as part of that, and then the other APs are going to hear your clients potentially better as well. So that's another, that's where things really start to get complicated, because one AP may hear the other AP at negative 90, negative 85, but what if you have a client that's attached to the AP1? What does the AP2 hear that client at, right? So there's a bi-directional piece that has to be taken into consideration.
Yeah, absolutely. Matt has a good question here. He says, does 802.11 have time slot assignments like TDM, OTN, or SONET, or round robin queuing to manage multiple client access for a channel? Matt, that's an entire webinar in its own, but it's a very good question. Basically, there is no centralized authority in Wi-Fi. Devices do what's called airtime arbitration. They basically contend for airtime, and so occasionally on the channel you get a little 50 microsecond breather. That is called a D something. Oh shoot, I can't remember what it's called. It's not a DTEM. I know it's something else. I don't know. I don't remember what it's called, but there is a 50 microsecond breather there, and that's basically a signal for all the nearby clients or radios that need to talk. And they all basically roll the dice, and they all count up to their number, and whoever rolls the lowest number gets to transmit first. And so that is called contending for airtime. That's an entire webinar. I'd love to do a webinar about that sometime. Matt, I hope that answers the question. I hope that helps a little bit. I know that was a very short, very quick explanation. Quick question from Wolken. What packet analysis software are you using? Wolken, the software that Jerry was using today is called Horst, Horst. Horst. Horst is running on a WLAN Pi, which is a little embedded Linux box that Jerry built. You can check out Horst. Just Google that. It is an open source tool. And you can check out the WLAN Pi at wlanpi.com. That's the little project that Jerry put together. Super cool little tool. I really like my my WLAN Pi. Thanks for doing that, Jerry. Really sweet project. Question from James. He says, quick question. What about other devices transmitting on the same channel at full power or running over our AP at half power? Any thoughts on that one, Jerry? What about other devices transmitting on the same channel at full power?
I'm not sure I quite understood the whole question.
Yeah, I think so. James, basically, here's what it comes down to. If there is something transmitting on the same channel as our wireless network, that will cause Wi-Fi devices to simply back off and be quiet. They will detect that, oh, there's something there. I believe that the cutoff from that is also negative 85 dB. If they hear something on the same channel at negative 85 dB or higher, that counts as what's called an energy detect. They go, ooh, there's something talking, and they will back off. It's been a while since I've dug around in the protocol, though. Jerry, am I on track at all there?
Yeah, it's starting to come back to me. I mean, I'm sure the chat room, if you will, probably can answer this better than I. But off the top of my head, there's two main factors there. There's the energy detect, and if it detects that there's energy, that something's talking on the channel, whether it can decode that information or not. So for example, like a microwave oven, it's not sending actual data, but it can detect the energy from the microwave. It's going to back off and not transmit. But then also if it's able to decode that frame, that is also going to be something that's going to trigger a back off, right? If it can actually receive something and decode it, then obviously it knows something is talking, and in that information that it decodes, there should be some type of information about how long that device is going to be talking for, so it knows how long to kind of defer or wait to talk.
Question from Kingsley is, what's the possibility of having channel 36 and channel 40 interfere with each other on a very high density network? That is an excellent question, Kingsley. Jerry, can you do me a favor, and can you zoom in on your upper channel, 40 megahertz channel that you got running up there? A little bit of activity on it. That's going to be the upper one of these guys right up here towards the upper end of the band, up above, up in Uni 3.
Oh, in Uni 3?
Yeah, way up in Uni 3. I think that's the best way to illustrate that. So what Jerry's doing here is, zoom in right on that. Yep, that perfect, that OFDM signature. What you'll notice about this signature, Kingsley, zoom out a little bit, Jerry, because I want to show them the sideband lobes that come off either side of that. In fact, maybe you might even be able, this is the perfect zoom level right here. Those sideband lobes, see how it kind of spills down into, what is that, channel 144 right there? You can, if you have two APs that are very close to each other on adjacent channels, maybe one on channel 40, one on channel 44, or 36 and 40 like you said, those sideband lobes absolutely can interfere with a neighboring access point that's on a neighboring channel. That is a form of adjacent channel interference. We tend to think of adjacent channel interference as kind of a 2.4 thing, but it can happen up in the 5 gigahertz band as well. Now, just keep your APs not, keep them not close to each other. You'll be fine. It's typically not a problem, but that's why, in a few environments I've seen bad Wi-Fi, APs are 10 feet from each other up on the ceiling. You don't want to do that because sideband interference can absolutely get you there. So that's the one corner case where that would work. So I hope that helps a little bit. A question from Jay, do you need the Ekahau Sidekick to capture all of this data or just the Ekahau Pro software? Great question, Jay. So the software needs a way to hear what's going on, right? It needs some ears, and the ears for the software are the Ekahau Sidekick. The Ekahau Sidekick has two 802.11ac radios on board for doing Wi-Fi scanning, and it also has a high-performance spectrum analyzer on board as well. So Jerry's got the devices window opened up in Ekahau here. Whoops, I tried to circle it right as he zoomed in. So we can see in the devices window that there are two Wi-Fi adapters, Ekahau Sidekick Adapter 1 and Ekahau Sidekick Adapter 2. And then we also have Ekahau Sidekick Spectrum Analyzer. And so those are the three radios that are on board the Sidekick that give us all this data. So yeah, you absolutely do need the hardware. It's just, we have to have it for everything, for all that stuff to work, right? So hope that answers the question for you. Paul has a question. Once you have, this is a question for you, Jerry. I'm going to ask you this one. Once you have detected an interferer, how would you locate it with the Sidekick? Does it have an external antenna port for a directional antenna?
Yeah, that's a good question. So no, there is no external antenna port on the Sidekick. However, this is a survey, purpose-built kind of device, right?
Why don't you full screen your iPad so we can...
What do you mean? I mean on this screen. Gotcha.
Yeah,
gotcha.
Make the window bigger.
Yeah. So let me see if I can pull up a project here real quick.
And while Jerry's pulling that up, the whole reason why we literally have an iPad pointed at a laptop is because that laptop that Jerry is running Ekahau on right now was subjected to all kinds of interference and connecting and disconnecting. And so we couldn't do a direct screen share from that because we have been messing with the network on that one really bad. So if you're wondering why it's 2018 and why Jerry and I are pointing a video camera at a laptop, that's why, is because we were seriously messing with it. So.
Oh, you mean there's a way we could have shared this screen easier?
I don't know. Not when we're introducing tons of interference.
All right, so let's look at, so as far as locating an interferer, I just pulled up a project file here real quick, and one way you could do this is, this is looking at the survey results, but I'm filtering out all the, measured Wi-Fi signals using the Wi-Fi adapters, and now we're looking at just the energy based on the spectrum analyzer, and this view is called spectrum channel power. So if you have, this is one way that you can use to filter this out. But what we can do is use this to tell us where did it detect some high sources of or high amounts of energy. And what I'm using is the legend here to define what is high amounts of energy. So if you're familiar with Wi-Fi and dB levels and things like that, you probably wouldn't see typically energy above negative 30, 35, 30 is pretty much as high as you'll usually see Wi-Fi, even if you're sitting almost right underneath an access point. So what I did here was I kind of cropped that out, and we're going to say, show me energy that was detected at negative 30 or greater, and maybe I can even color code this to even help to paint that picture of where the source of that energy is coming from, right? So we could give it like a hot to cold, and so where the signal is the warmest, that's where the energy is emitting from, right? So this is not using any kind of directional antenna, but literally just walking around the building, clicking on the map of where we're standing, and we're creating heat maps to locate where the source of that energy is being emitted from. And we can even, give this a little more granularity to our coloring. I can even set my spacing all the way down to like 1 dB increments. And now we can see a nice pretty picture here and drill down all the way down to a room level of where the source of that energy is coming from. So you can see here we had some really high energy coming from this room, and it was on channel 132. We also saw some energy in this room over here that would be worth investigating, maybe a little lower power transmitter here, and that one's on channel 153. And then we can drill down into that, using the data that we captured. So using that same view that we were kind of looking at during the other demos, we can go into our survey playback mode. Think of it as kind of a DVR. We know that signal is on 5 gigahertz, and sure enough, we can see this really high power transmitter here on channel 132, and I can zoom in on that. Now, this is a survey we did months ago, but we can still play that back. I can walk through the survey step by step and see exactly, when we went into that room, when we were close to the source of that energy, what that signature looked like. And we can even pop this out into a full screen mode if we really need to drill down into this further. You can zoom into that level of detail.
So basically, what you're doing is you're doing a site survey, which is going to gather spectrum analysis data as you move around, and then we can basically map that signal strength from a specific channel, not the signal strength, but spectrum channel power from a specific channel onto the map, and use that to figure out where the interferer is.
That's right. Yep.
Right.
So that's one way you can do it. Obviously now with the interference detection capability that is in beta, that's going to also help to pinpoint, along your survey path, where did you detect that camera or that microwave, where was it on the map, and you can zoom to that level, so it would pop up, a thing on here showing, hey, there was a video camera in this spot in your survey, and you can take this and just slide it to that spot and then look at the map and see where you were standing when it detected that interference.
Very cool. Vitality has a question. Is the jammer illegal?
Well, I don't like to call it a jammer to avoid any kind of issues with that. It is a very low power. So like I said, it's not very practical for those types of, really malicious type things. It's great for labbing. I like to think of it as more of a signal generator. I know they call it a jammer in the Havoc application, but yeah, it's really, it allows you to generate some signals and different channels, different frequencies. But yeah, as far as the legalities go, you may want to check with your local regulations there.
The way that I see it, and I don't know whether this is corresponds with reality or not, but the way that I see it is that generating a signal in 2.4 gigahertz is perfectly legal. Same with 5 gigahertz. That's what we're doing with Wi-Fi is we're generating signals. What is not legal is intentionally jamming someone's network. And so, if you're showing up with if you show up with a Nuts About Nets air horn and you jam out your competitor's wireless network, that's definitely not okay. That's very illegal. However, Jerry, running a signal generator in his home lab to study the effects of RF being introduced on the same channel as your network, I see that as being very different. And we are very careful about when and where we will operate those because we never want to intentionally or even unintentionally, we don't want to mess with anyone else's Wi-Fi. We want people to like us too, so we don't want to be jerks. Darren asks, what firmware are you using on the Hack RF and the Porta Pack?
It's called Havoc.
Havoc, cool.
Yep.
All right. Well, we're at about 11:05. There are no less than 52 unanswered questions. So, Jerry, what do you think? Should we wrap things up or should we keep going? What do you think we should do?
You don't have any plans the rest of your day, right, Joel?
No. I'm good to just sit here and answer questions all day. I just want to be respectful of everyone else's time. And so let's do 2 more questions and then we'll call it good. And we'll keep going just with a couple more here. So a question from Jamie, is there a way to block a Porta Pack jammer? Unfortunately, Jamie, no. There is no way to block any kind of interference. Once interference shows up on a channel, it's already on the channel. There's no way to restrict that from happening other than physically locating it and shutting it off. That's the only thing that you can do to get rid of interference. Alternatively, you can simply move your AP to a different channel. If somebody brings in a wireless video camera onto your network and it starts to jam a channel, well, the only thing that you're going to be able to do is to simply move to a different channel to get away from that interference. And that's okay. It's fine. If you've got the spectrum available, if you've got another available Wi-Fi channel somewhere, then you can go ahead and just move your network off to a different channel. And basically what you have just done is you have performed some spectrum planning and you've just got rid of that. So
yeah, the other thing I would say onto that, but beyond moving channels, we've got all sorts of, AI type stuff now that'll, the clean air type things that'll check the channel utilization and move to different channels if it detects interference. The other piece of it, though, is, physical location. So you may not be able to remove that source of interference, but now that we know that office, like we were looking at, has some type of interfering source in it, I'm going to factor that into my design or my remediation plan, and I'm not going to install an access point inside that office or right outside that office. I can now see what is the area of impact by that interfering source. Like I said before, it's all about how close the source of interference is to the receiver, and the receiver being both the access point and the clients. So yeah, at least we can, kind of control one side of that potentially and not put the access point, which in my eyes is the more critical piece of making sure the AP isn't near the source of that energy, since that has to communicate with multiple clients.
Yeah, absolutely. Okay, I think we had one more question. Carlos asked, does the different signal colors have a particular meaning? And I think Carlos is referring to the utilization or the density view in the spectrum analyzer. So if you were to open up, back in here. So Carlos, the different colors in here, color indicates how often that particular frequency is being used at that certain loudness. So anywhere that's green is very short signals. That means something's only happening there like 5% of the time or so. Anywhere that's red means that there's something happening there a lot. Maybe that's 50, 60, 70% utilization. So, okay, so with that, I think let's go ahead and link people to our let's go ahead and link people to our very cool infographic. So Jerry, I'm actually going to steal the screen back from you really quick here.
All you.
All right. I think I got it here somewhere. Okay, so what I wanted to show you guys really quick is we actually put up we built a cool infographic. We've got some really good graphic designers here on our team here at Ekahau, and they put together this awesome infographic. And so you can see that little shot of it here on the screen. If you go to ekahau.com/resources, ekahau.com/resources, you can download that infographic. If you got a good printer in the office, go ahead and print that thing off and stick it on the wall. It's a pretty cool infographic. It's got a little snapshot from the spectrum from each source of interference. I'll give you a little preview of one of the larger ones that you can. Oh man, I just lost it with. Here we go with PowerPoint. So yeah, here's an example of what you are going to find on that infographic. Here is a game controller, and we kind of define what type of device it is, what it looks like in the spectrum, and what the power output and what the threat level is going to look like. Here's a drone, and so these are all things that you can see on that cool infographic. So go grab that. Go grab a copy of that infographic from ekahau.com/resources. And if you have any questions going forward, feel free to get in touch with Jerry and I. Twitter is a great place to do that. Jerry is located at JOla on Twitter, and I am located at potato_phi on Twitter as well. So we'd love to hear from you there, and we'd love to answer any of your questions that we didn't get to today. So, anything else, Jerry, before we end the webinar?
I think we covered as much as we could in the time frame we had.
All right, cool. Well, hey, everybody, sorry, big apologies for all of the issues and stuff, the technical problems with today's webinar. Even though Jerry had a pretty complicated setup over on his end, really the reality is it was just a screen sharing issue. And so we've got we'll talk to Zoom about that. And we'll see if we can get that resolved for next time. So thank you so much for being here today. We really appreciate it. And we will look forward to seeing you on a future webinar. And also keep an eye out for a follow-up email from us shortly containing a link to the recording for this webinar. You will receive that within 24 hours. Thank you so much and have a great rest of your week.
Thanks, everybody.